This could very well be a video that you'll find yourself referencing at different points throughout the year. Significant figures. I kind of mentioned the term in an earlier video. It refers to all of the parts in your measurement. So all the numbers that you measured off your measuring tool plus your estimate. That is considered a significant figure. It's an important part of your measurement. When I look at a number or a measurement, there are some rules for deciding if the figures are significant. You'll often see this referred to as sig figs, a little shortcut. So you'll be stalked by sig figs throughout the entire year. So if it's like after Christmas and you went on vacation and you come back and you have no clue what a sig fig is, you may find yourself wanting to look at this video again. Okay, so easy. If you have a number, let's say we had 35.98 grams, or whatever the measurement might be, all non-zero numbers are significant. They're all part of the measurement. And remember that the last spot is always the estimate. So we'd say this was the estimate. So with whatever measuring tool they were using, they knew for sure it was 35.9. It was just a hair less than 36. So they estimated 0.98. Whatever this measuring tool was, they had a line for 35.9, and the next line would have been 36.0. So they estimated the hundredths place. Now obviously if you're using an electronic balance, you don't have to estimate. This would be if you're using anything where like you are making a human measurement. All non-zero numbers are significant. So all digits 1 through 9. Anything from 1 through 9. They are always significant. They are always part of the measurement, including the estimate. Okay, so we have 6 rules here, which means the rest of them are all for stinking zeros. Zeros can be kind of a pain in the patootie. Alright, so here's zero rule number 1. Here I guess it's listed as rule 2. All trapped zeros are significant. By trapped, we mean zeros that are between non-zero numbers. So for example, these are trapped zeros. This 0 is between the 4 and the 7, and this guy is between the 7 and the 2. It doesn't matter if there's a decimal spot in there. All of those zeros are part of the measurement. The 407.0, and then the last one, the 2, that was the estimate. So they knew that it hit the 407. They knew that it did not hit the 407.1. So they're going to estimate 0.02. Those zeros are part of the measurement. So if we saw something like that, we would say there are 5 significant figures. Excellent. Even if I had something a little crazier, like, I don't know, maybe it was 4,000.002, something like that. All of those zeros in the middle are trapped zeros, and they all count as part of the measurement. So we would say this is 1, 2, 3, 4, 5, 6, 7 sig figs. Oh, it's all a breeze, right? This is so easy. Rule number 3. Okay, so here's where things get a little more fun. Leading zeros are not significant. By a leading zero, we mean a 0 at the beginning of the number. A 0 leading off the number. Whatever this is, it's going to be a small number. So this refers to small numbers. If they start with a bunch of zeros, like 0.00000, whatever it is, this is really small. Whatever it is, I didn't have anything to physically measure in the ones place, or the tenths, or the hundredths. We didn't make a measurement until the 0.007, and then the 5 was the estimate. Those leading zeros were not physically measured. whatever this was, it was really small. So we didn't really start making a measurement till the 7 and the 5 was our estimate. And both count as significant. Now this would be the same as if you had like 0.0075. Sometimes people will ask, like, do I need the 0.00? Like that 0 out in front of the decimal spot? No, if you put it in, it's fine. If you left it out, it's fine. Either way, it's not significant, and neither are these guys. So both, we would say 2 sig figs. So if there are any numbers, or any zeros, I should say, that lead off a number, ignore them. Those were not physically measured. Okay, so zeros tracked in the middle, yes, those are significant. Zeros leading the number, zeros in front, no, not significant. How about zeros on the back end? Rules 4 and 5 are kind of related to each other. If there are zeros at the end of a number, you need to look for a decimal spot. If there is a decimal spot in the number, like if I skip ahead to number 5, that decimal spot is very important. If they put a decimal in, then that means yes, all of those zeros at the end of the number are part of the measurement. And we say there are 4 significant figures. Sometimes we really do measure 0, or sometimes 0 might be our estimate. That's okay. To show that you want those zeros to be part of the measurement, you have to put a decimal spot at the end. So if there are zeros at the end, and you see a decimal point, those are all part of the measurement. Now backtrack to this guy, 2,800, with no decimal spot. If there's no decimal spot in the end, it means that the number was rounded. That was not the original measurement. Maybe the original measurement was something like 2,815. And there are times when we want to round. And so what if for some reason we wanted to round this to 2 sig figs? Or we wanted to round this to the nearest 100? Okay, so you'd round it, 2,800. But to show that these zeros were not the original measurement, you do not put a decimal spot in. And then the only 2 figures that are significant are the 2 and the 8. Those zeros were not measured. So to show that, I don't put a decimal spot in. Now, if somebody did want those to be their measurement, and again, that could happen, where you say, okay, I know that it hits the 2,000, I know that it hits the 800, it does not hit the 2,810, and by golly, I think it's right on the line. If you want those zeros to be part of your measurement, then you must put a decimal spot. Now that would be 4. Obviously, this number is also 4. Or sig figs. It's easy when you don't have to worry about zeros. Zeros at the back are usually where people have the most trouble. Look for a decimal spot. If there is a decimal spot, then all of those zeros count as part of the measurement. If there are zeros at the end with no decimal place, then they were rounded. And they were not measured zeros, so they are not significant. And again, that could happen. There will be times when we want to round a number. And to show that it's rounded, we just don't put a decimal spot in the end. The last one, this rule number 6, any zeros at the end of a number, as long as there's a decimal spot anywhere in the number, they are significant. Okay, so this guy here, again, this would have been our estimate. They knew it hit the 34.1. It did not hit the 34.11. And we're going to estimate that's right smack on the line. You can have zeros as part of your measurement. If there's a decimal spot anywhere in the number, those zeros at the end count. Those were measured. If they didn't want those zeros in, then they'd leave them off. So you could have like 34.10. You could have 34.1. The last spot is always the estimate. This would tell me that they had different measuring tools. One of the things that we'll kind of use when we refer to measurements like this is that term precision. Earlier we mentioned that precision refers to having reproducible data. It also refers to how detailed your measurement can be. These are not the same measurement. The zero at the end tells me that as I go from this first measuring tool to the second to the third, this last measuring tool had way more detailed markings. There would have been a line for like 34.11. And I'm saying, no, it doesn't hit the 34.11. I think it's like right smack on the 34.1. This measuring tool would be the most precise. It gives us a measurement with the most detail. So obviously when you're making your measurement, you got to be careful as to how many figures you can report. And yes, you can estimate zero at the end, and it's very important to put in that zero estimate. And now when we're looking at these numbers in terms of significant figures, measured figures, the more significant figures you can have, we'd say the more precise that measurement was. The more precise the measuring tool must have been. Okay, so in conclusion, anything 1 through 9, significant forever. Zeros in the middle, significant for life, always significant, always part of the measurement. Zeros in the front, never. They're always placeholders. They're never, ever, ever measured. Whatever it is, it was something really small. Zeros at the back end, look for a decimal spot. If you have a decimal spot anywhere in the number, all of those zeros at the end are significant. If there's no decimal spot, the number was rounded, and they are not part of the original measurement. So again, I would pause the video at this point. There are a few little sample questions I'll ask, just how many significant figures are in these numbers. While this is kind of fresh in your mind, I would give that a try. Again, I'm never going to collect this, or you're never going to turn it in. It's not for points. It's really just to see if you are in a good place. Are you grasping this concept? Because now this is probably something that you did not do a whole lot of in a previous science class. So I'd probably hit pause, give these a shot. You don't even need a calculator, and then bring it back to see if you are getting them right. Okay, so let's see if you got these right. Obviously, number 1, 3 sig figs. Number 2 is just 1. There are zeros at the end, but there is no decimal spot. Number 3, there are zeros at the end, but there is a decimal place. They all count. All 4 of those zeros at the end are significant. Number 4, we got some leading zeros. These are just placeholders. They are not. But the trapped zero in the middle, that guy counts. So there are 3. Similar, I guess, with number 5. The leading zeros are not significant, but these guys at the end are. And we do have a zero at the end of the number, but there is a decimal spot in the number. So yes, they are all significant. Those 3 at the end, the 630. The last one, we should make note. In scientific notation, the significant figures are what you leave out in front. You do not need to put this in long form. So if somebody has just 6.4 times 10 to the 5th, they mean for just the 6 and the 4 to be significant. For example, if you had, let's say you had, I don't know, 5,000. Kind of like number 2. If you read this as 5,000 with no decimal spot, we said, yeah, 1 sig fig. Another option would be put this into scientific notation. And so we could just add a decimal at the end and go 1, 2, 3. And then we could just say 5 times 10 to the third. And if we just leave it as 5 times 10 to the third, it's just 1 sig fig. In scientific notation, you drop all the zeros that you don't want as part of your measurement. If the number was rounded, then we only show the significant figures in front. Now, what if you had something like this? If you had 6.40 times 10 to the 5th, these are all significant. Now this would be 3 sig figs. In scientific notation, what's meant to be significant is what's left out in front. This can be a good way of rounding as well. You get some giant number on your calculator and maybe you want to round it off to something more reasonable. You could put it in scientific notation, and then whatever you want to be significant, that's just what you leave out in front. So again, hopefully you're on a good place with these. We're going to practice this in class quite a bit because I know this is something that's a little bit new. If it's not clicking whatsoever, red flag, come on in and get a little bit of help.